Good morning, everybody. So let us start our lecture today. And today is October 12th. So we are in the second half of this course. So we completed until we completed linked list, tag, and QE. So this week is October 11 to 17. This week we will cover recursion. So recursion is an interesting topic. It has very use in computer programming a lot, especially for implementation like other trees, BST, graph, and higher level data structures. So recursion is widely used. So we will cover recursion today. So in the slide, if you go to the D2L, then content tab and go on the left side. The content 15 number, maybe 15. Yeah, 15 is recursion. It's chapter 9. So I added one more PowerPoint slide over here. That is from our 1322 course. So I think everybody is familiar with recursion since you took 1322. If you took 1322 with us or CS2 course. So this will be just a review for many of you. Okay. So let me start with the slide. So if you download, click on over here and download the slide. I have already downloaded it. So let me open it here. Let me open the book first. Okay, the book says the chapter 9, the title is Recursive Thinking. Okay, and then we generally call it recursion. Recursive thinking means rethinking, thinking again and thinking again in the same fashion, but with a different scope or different domain. And rethink, we continue our rethinking or recursion until a certain point. Until a certain point for our domain scope, that is called base or baseline. Okay, so let me go through the book. This maze game. Okay, we will go through both book and our slides, but for instance, this is a good program. Yeah. We'll come back here later, but let us think that our slide. Okay. So recursive thinking or recursion is a process of solving a large problem by solving its simpler version. Okay, that means by solving its sub-problems. Okay, so the process is called a recursion. So when a function calls itself, then it is called a recursive function, and the process is called recursion. So recursion is a process. Okay, so it is a function. So recursive. So recursion is a mathematical concept. Actually, we know this is familiar with mathematical. Many in terms we use a recursive process. The process can be any kind. It can be multiplication, it can be addition, it can be division or subtraction, anything. Okay, or it can be printing something. Okay, so like for instance, retrieve a process. For instance, we will say tree letter. So whenever we have a tree, we have a root, and then it have branches, and each branch has sub branches. So as we know that in modern time, so a tree is called grafting, right? The grafting way, a branch is grafted to make some roots over here, and that branch is cut, and that is planted as a new tree. And after few months or few years, that branch become another tree. Okay, so the process, that is same process, is called recursion. Okay, so actually the recursive process or recursion, it follows a pattern, and using that pattern, it continues until some steps. Okay, so whenever you take it's called programming languages class, then you will see how the program compiler are developed. So how the compiler developed. In that case, you will see the recursion is widely used. So for this chapter, please give attention and understand this thoroughly. Clearly, if you have clear understanding about recursion, then you will see that many other complicated things easy, for instance. So you may hear the name of the language Scala. So what some other functional programming languages like F# or other functional languages you are familiar with. So these languages widely use recursive methods. So something, for instance, we know that list of numbers, okay, or a set of numbers. A set may contain, it does not contain duplicate elements, but a list may contain duplicate elements. Okay, for instance, this is a list of number 24, 88, 40, and 37. These are the actual numbers, and we know that in order to present this number in a list, we use comma. So these numbers are comma separated, right? Or sometimes it may be separated by space. Okay. Or something else. But here, so in generally, we know that in an array, the elements are whenever assign value to an array, we separate the element, the numbers, array elements by comma. Okay. So for instance, a list can be defined recursively such as follows. For instance, a list in uppercase, that is a keyword. For instance, this is list. So list is a number, is defined as a number or number in addition to comma, number, comma, followed by list. So what does this mean? So this one. Sometime in some book or in programming languages, you will see something instead of or over here, you will see bar over here, just bar. That means what? And instead of is over here, you may see colon over here in some languages. So whatever say in pseudocode or in this is a pseudocode format. Okay, so whatever you see, just it's easy for the pseudocode format to understand. Okay, so what is it over here? So this is a list. How a list is becomes a recursive. So list can be number. So number, what is mean number? This 2, 24, 88, 40, 37. These are the number. Okay. For instance, a list can be only with one number, 24. If there is more numbers with it, okay, and then it can be this 24, the number, then comma by another list. So how is this? The previous list is defined. So previous list is defined as number, for instance. So we say that is 24, comma, we can say another number. So that is 88. Okay. And it may end over here. It may end over here, or it may continue with a comma followed by another list. Or it may be here 24, comma 88, and then comma another list. This list also can contain, this list can contain either number or another number followed by a list, comma, then either number, comma, followed by a list. So that means this may be 24, then 88, then comma, then another, then the comma list, the list may be something, maybe 40, and it is maybe 37. You see the last one is list. So list, what is the base case of a list? Is a number that does not have comma after it. Okay, but the second option has comma. So the last one is the base. This one is the base. It does not have any comma after it. Okay, so that here. So that is a list is defined to be a single number or a number followed by a comma followed by a list, or a number, okay, or a number. I want to say this together. This together. Either a single number, a list. Then if the list contains only one single number, then that is a list. This is the initially the 24. Okay, and that's it. That what if it contains, if it is not single number, then how that will be growing is for comma. So that second part, what a number followed by a comma, that is a number followed by a comma. Okay, you follow it by a list. So by saying followed by list, that means it is growing. Okay, so how long it is growing? It has a limit until it, how many elements it has. That is called limit. Okay. So this can be confusing to some of you, but if you go through this explanation, then it should be clear. So does anyone has any question about this? Everybody is okay?
Yeah, I'm good.
Okay, that is from take home from this list is that the concept of a list is used to define itself. Okay, and it is used recursively. Whenever we say the word itself, then it is more probably that this is a recursive process. So the recursive part of the list definition is used several times, ultimately terminating with a non-recursive part. There is a non-recursive part, that is the base case. So for instance, here again that I discussed in previous, I wrote over there. So number and comma list. This entire part is a list, and then this list, okay, is formed by number, then comma, then another list. So this list is a sub list. It has fewer numbers than the previous list. So this list is formed by number, comma, and then another list. So we saw that the definition of list, it can contain only a single number. Okay, that is the base case. For a number followed by a comma followed by a list. So here this is the first case. It can list can have a number. Okay. So this is the base case, and this is the expanded case. That is the case for, so the first case, so this is the base case, and this is the alternative growing recursive case. So base case, it goes all the way end. Okay. Now, so base case is a non-recursive case. Remember that always the base case will be non-recursive, where the recursion will terminate. Okay, so actually we'll see that a recursion is a process of, is an alternative process of loop, is an alternative loop process. So we know that in a loop, when a loop terminates, when it reaches to its condition, then it terminates, right? So similarly, when a recursion will terminate, recursion process will terminate, and then it will start refolding when it reaches to its base case. So as we know that without a condition, a loop becomes an infinite loop. So without a base case, a recursion process will be an infinite recursion. So we don't like to be an infinite recursion or infinite loop. So we need to stop at after certain iteration. So that is why we need to have base case. So every recursion process has a base case, must have a base case. We will see how what is the base case. So base case depends on each situation. Different numbers or different recursive process has different base case. So actually, a recursion is a mathematical process, and if we say mathematical process, so then finding factorial of a number is an ideal example of recursion, and it is widely used for recursive process to demonstrate or illustrate recursive process. So for instance, how do we know the factorial of a number in mathematical definition is there? If it is 1, it is 1 if n equal to 1, that is factorial of 1 equal to 1, we know. Otherwise, we know that factorial of n equal to n times factorial of n minus 1 factorial. Otherwise, so in English, if we write in English, plain English, how do we write this? We say factorial of n equal to 1 if n equal to 1, or we can say if n equal to 1, then factorial of n equal to 1. Otherwise, factorial of n equal to n times factorial of n minus 1. Okay, so that means the factorial is defined in terms of another factorial. This is the another factorial until it reaches to its base case, or that means factorial 1 is the base case over here. So if we write here, we know that factorial of 5 equal to 5 into 4 into 3 into 2 into 1, right? So then what is this one? For this one, this is also factorial of 4, right? So that means we say factorial of 5 equal to 5 factorial equal to 5 times factorial of 4. Okay, if you write this way, do not forget to give the dot. This is going to be exclamation sign. Otherwise, it will mean 41. Okay, and then we know this is 5 into 4 into factorial of 3. So this part is factorial of 3, right? So it is a 5 into 4 into factorial of 3. And similarly, you can write 5 into 4 into 3 into factorial of 2. This part is factorial of 2. And then we can write 5 into 4 into 3 into 2 into 1. So instead of factorial of 1 on here, give me 1 second. So factorial of 1 actually here. So we know that this is our base case, factorial of 1 equal to 1. So 5 into 4 into 3 into 2 into 1 equal to 120. Okay, so factorial of a function is used to illustrate the basis of recursion process. Okay, so everybody is okay.
Yeah, so far so good.
Okay, it's simple. I think everybody who took 1322 CS2 course, you are familiar with recursion process. So for instance, for x is any number, factorial 5, we know that factorial 5 equal to like 5 into factorial 4. Okay, but what we want to recall from here, so the recursion process, it comes, the result comes reverse order. So actually in the in our natural mathematical process, for instance in multiplication process, how do we we multiply this way, right? Okay, so we multiply 4 times 5, 5 times 4 times 3 times 2 times 1, but internally, since it is computer use stack. Okay, so internally in recursion process, computer program uses a stack. So in this stack, so stack hold some values. We know the stack is a last in first out type data structure, and then how the stack will update I will show you soon. But here, so whenever it is base cases, so the base cases is then it gets the stack value, the stack value, and then it comes to the result final. Let me see. It has this. Okay, the book has a Hanoi tower, so I will come back here. Okay, I'm moving to another slide. Okay. So we discussed this, so that sometimes, so whenever in a recursive process, the control moves from one function to another function. So the transfer, the method call, okay, is controlled by actually resumed by using a stack. Well, I'm coming back this soon, okay. But another example of recursive method, for instance, adding up some numbers. Okay, summing up some numbers. For instance, we said this is summation sign or epsilon sign. Summation I equal to 1 to n I. How do we add up these numbers? Okay. That is, we say, for instance, in mathematics. Okay, so whenever we write like this, summation of I equal to 1 to n I, we usually write this way: 1 plus 2 plus 3 plus 4 plus dot dot plus up to n. We write this way, right? But actually, if we write reverse order, from that means n, and what is the previous number here? So let me write it down: n minus 1. Actually, n minus 2, we can say n minus 2 plus n minus 1 plus n. Like this way, the number grows this way, right? So here, then we can write n plus n minus 1, this number, this term, plus this previous term, n minus 2, plus this all other previous terms, dot dot plus, we can say 4 plus 3 plus 2 plus 1. So then what is this term for over here? So we can say this is n, this is plus n minus 1, n plus n minus 1, this term, plus, and up to this, here I start from, if we do same pattern over here, so here I start from 1, this is the last one, 1, and it ends with n minus 2. So then we can write this term plus I equal to 1 to n minus 2 I. So this is written over here. And similarly, we can write that n plus n minus 1 plus n minus 2, and then what is the previous term over here? I equal to 1 to n minus 3. Okay, like this way. So this is in recursive process. Okay, but in regular mathematics, we start from 1, 2, 3, 1, 2, 3, 4, 4 up to n. But if we just start from the end, then you will see the recursive process. Okay. So here in this process, what is the base case? Can anyone please tell me? In this case, what is the base case? If this is a recursive process, what will be the base?
Would the base case be 1?
Yes. Base case. This is our base case. Oh. So base case is the situation where we will stop our recursion. Here in this mathematical expression, it is given, the base case is given over here. This is the base case. N equal to 1. Okay. And now later we'll see how to write code for this recursive method. Okay. Okay, code is over here. Let us, before we switch, let us think that. So a recursive process is, since it's a process, it is written as a method. Okay. And usually all recursive method takes at least one argument, one parameter. One parameter. This is the sum is the recursive method. It does not need to say that this is a recursive method, but its pattern will tell that this is a recursive method. Okay. So you can write the method name. You may say recursive sum. It is okay, but you don't need to write. Mention the recursive. Okay, a recursion. The process is called recursion, and the method is called recursive method. So you don't need to write the word recursive. I mean, you don't need to mention the word recursive in the method name. It will be assumed by looking its code. Okay, but it's optional. You can write it recursive sum. Okay, so but one thing is that remember that all recursive methods that take at least one parameter. So this parameter value will tell us what is the base case. So if int result, so result is another variable when wherever it holds the result. The result will be sum of some numbers. Okay, this coming with that. I don't need comment over here. Okay, so you say that if number equal to 1, so this is a logical operator. Sorry, not logical. A relational operation over here. If number equal to 1, then result equal to 1. That means what is this is the base case. What is the base case? If there is only one number in the series, and that is the base number, so result will be 1. Okay, else otherwise here the recursion happens. Result equal to num plus sum of num minus 1. So here this is the recursive call. This method will call itself, the recursive method will call itself, okay, until it resets to this base condition. Okay, so that means if number equal to 1, the result will be 1. If number equal to 2, then result will be 2 plus the num plus 2 plus sum of 1. What is sum of 1? We know that from previous step, whenever number equal to 1, then so sorry, the the mistake over here. So this either this is will be lowercase s here, so lowercase s, all of this or this will be uppercase. Yes. So function name on this will be match. Okay. So this most of the languages are case sensitive. So let us consider that S is uppercase S over here. S is uppercase and S is uppercase over here. Okay, so then if number equal to 2, the number we pass over here to this method, sum method is 2, then say result will be 2 plus sum of 1. Then we know that sum of 1 from the previous case, the base case, it will come 1, so the result will be 2 plus 1, 3. Okay, and it will return 3. Okay, this return will 3. What this return will this value is returned? It will be returned through the previous or later call, next call. So here the next call. So for instance, if n equal to 3, its number equal to 3, then it will call the sum 2. So the sum 2 it itself calculated sum of 1. So but the sum 2 it does not need to recalculate the sum of 1. It just will use its previous result. So the process, the the entire process will take less time. It will not do the recalculation. It will use the recalculation method, previously calculated method. And so it will go on, okay? So there are other numbers. So there is an example over here. So let us come back here. Sorry. Okay, so this is a simple implementation of a recursive method that will add up some number, a series of numbers, okay, linear numbers, 1, 2, 3, 4, 5, 6, 7, like this. So in this series, for instance, if you pass, so in this series, if we call this function with sum of 10, so that will return 55, right? That is 1 plus 2 plus 3 plus 4 up to 10 equal to 55. And if we put sum 100, that will return 5050. Okay. You can try with this. Okay, now in the next pages, there are some code snippet. Okay, and for now, it is homework for you. Look at this code, and we do not run this program again, okay? To spend some time to understand what is happening over here, what is the base case over here, and what will be executing if we run this program. Okay, and try to understand and try to find the base case first, and then okay, then find out the output. What will be the output for this code snippet? So that means, for instance, what will happen if we pass value 3? We will call exercise 3. Instead of n, if we pass 3, what will happen? Okay, try to do this. Okay, this is for homework for now. Okay, and this is another version of the previous program. You see that here the output statement is reorganized differently. Then what will happen for this case? And maybe there will be another version here. What will happen for this case? Okay, and then what I like you to do not look at the next slides, please. These are the slides that you have the result, for instance, here. But start from this one, from exercise 1. Okay, then if you are whenever you understand these, then go to the next one, and whenever you understand these, then go to the next one. Then you will have something. Does anyone has any question? There are 21 students. It should be 21 students. Okay, let me take the attendance for today. Okay, today is 12th October. Okay, So please respond to my roll call, okay? Attendance call. And Jason.
Here. Hello.
Yes. Okay, thank you. Matthew Ashford. Daniel Myers.
Here.
Antonio.
Here.
Jamie.
Here.
Tetron. Elisa.
Here.
Tyler.
Here.
Ernest.
Here.
Angel. Jaden.
I'm here for Angel.
Jaden is here, right? Cody. Isaiah. Jimmy.
Here.
Savvy.
Here.
Loyal.
Lowell's here in the comments.
Here.
Dave here, right?
Yep.
Karen. Mikhail.
Yep.
Zayas. James.
Here.
Brandon. Noah. Alan. Kenya. Kenny, are you there? Jimmy. Lilivia.
I'm here.
I saw Jimmy is here. Jimmy. Oh no, Jimmy Logan is here. Okay. Jesus. Cameron. Sebastian is here, right?
Yeah, I'm here.
Alice.
I'm here.
Justin. Daniel. Andrew.
Here.
Nicholas.
Here.
Jessica. Is anyone missed? Loyal. Luke is here. Loyal, Luke. Okay, got it. Okay, so this part is for you as for your in-class activity or for your homework, right? Okay, so please do not write the program fast. Do not see the output fast. Please spend some time maybe 5 minutes, 10 minutes, 15 minutes if it's that. But you don't need to spend too much time. Okay, 15 minutes should be maximum time spent. And I think you understand this. Okay, for instance, if you whatever you understand, write down your result. If you think something like differently, okay, write your result 1, result set 1, result set 2, result set 3. So if you have different understanding in one thinking, write it down. If you have another understanding in another thinking, write it down separately. And then whenever you think that, okay, you have completed all of your thoughts, then run this program, write this program. You know how to write this program? Write this program as a method and then call this function. Call this method within main method. Just pass it instead of int in over here, put any value, maybe 5 or 10 or something. Then see the output here. Output and match the output over here. So one thing is stay there is this, there is a DL. And every output will be printed in one single line. One number will be printed in one single number. Then you'll go next. Enter next line, new line. Okay. This is another method, another recursive method for. And then in our next lecture, we will go Tower of Hanoi. This is a good thing. The book has this recursive process. But let me spend some time today from the slides. Not this one. This one, I added this one in D12. So this slide is from our 1322 course. So I think it would be easy to, we have a few slides, 15 slides about. We'll spend 15 more minutes. Okay, so recursion, as we discussed, that a recursive method is a method that calls itself. Recursion is implemented in programming as a method function. Okay, and a method that calls itself. Calling itself is the first criteria of a recursive method. Okay. A recursive method is capable of solving only base cases. Okay. So, what does this mean? A recursive method is capable of solving only the base cases. It can have multiple base cases, but it solves. So it says only. What is this word mean by only? That is a good question for us. Here only means whenever the recursive process solves the base case. And this is rather simple. Base case is very simple sometimes, right? It has only one, something like this. One statement. So here, this is the base case. So this is the base case. This is the base case. Here, I'm not telling this one. This is the base case. Okay. It will be given in the method. Okay, so it says the recursive process is capable of solving only the base case. But then how the entire process will be solved? The entire process will be solved recursively. Whenever it solves the base case as base value, then it will call recursively, iteratively, and then it will be solved automatically. We can say for now we can solve automatically because the process it uses a stack. We don't see the internal functionality of stack. Okay, from outside our program output part, so that for now, let us think that it is processed automatically. Actually, the compiler compiles it. Okay. So a recursive method recursive, the sequence of returns ensure until the original method calls returns to the result to the caller. What does this mean? Let me go with an example and then we'll see that. Okay. Okay, so stack is used for the recursive process. So in stack, we use the concept of activation stack to keep track. This is not stack, this is track. Okay, remember that. To keep track of memory and the instructions live inside each method. Okay, when a method is invoked, a new frame for it is placed atop of the activation stack. Okay, when a method is finished, the frame is removed and the control returns to the next frame down. Okay, so this is the first stack operation. Let us go with, let me see if I have the stack. Yeah, we have the stack over here. So we will come this if we come over here. So a function, for instance, a function is a recursive call. How a recursive call is executed. So here a recursive call, a function, it calls itself, right? It calls itself, it calls itself, it calls itself until it returns to its base case. So whenever it returns to its base case, actually for instance here, okay, you see that function, how the stack, how it's called stack. Okay, so the function okay, so whenever it stacks, since stack is the last in first out value, the stack is it holds the base case at the end, all the way bottom, the base case. Okay, for instance, base value, base case over here. So whenever it goes to the base case, then this value, so here, so this value is over here, then it returns to the previous case, it returns to the previous case, and returns to the previous case. And is that finally in one way it is going to the measure function with the calling value, and then it is approaching to the base value. Okay, I think it will be clear when we explain this with the factorial function, recursive call. So let us go to the factorial function. So here, let me highlight this one first. So recursive methods, the design technique is just, it has mainly two major steps. The first phase, it determines the base case, that is, what is the stopping point for the recursion, when the recursion stops at the base case. It should normally be the simplest case. Okay, as we said that the base case is simple. And the second case, what is the case that is just one step above it, the previous step. Okay, can it be generalized enough to fit? for all cases, all other intermediate cases? If it is yes, then that process goes to the recursion process. So here, let us see this example. So 5 factorial number is factorial of n equal to n times factorial of n minus 1